Hi there and welcome to this video on senior physics for electromagnetism and electricity. In this video we're going to explore how electricity can be generated. Now as we know, we can use a DC motor to basically produce movement in an armature or a coil of wire which is interacting with a stationary magnetic field. From this we can produce this kinetic energy. So it stands to reason that if we went in the reverse process, we could be able to use kinetic energy, use that kinetic energy to rotate either a coil or a magnet, and as a result we would generate electricity in the reverse direction. Well, this is what generating electricity is all about. It requires the concept of using some form of kinetic energy which is going to cause a magnet or a coil to rotate between each other so we get some interaction of magnetic fields. This interaction of magnetic fields produces a force. This force will be applied upon the movable electrons inside that current carrying wire, and as a result we will generate electricity. So if we take this example here, we can see we've got a wind turbine. Now if we open up that wind turbine, what we basically see is we've obviously got our blades. Now our blades are going to interact with the wind and produce our kinetic energy. Now if you follow through with the diagram that you've got there, just to the left of the engineer, you can see you've got your electrical generator. Now the electrical generator will basically consist of the following things. And you can see below, what we tend to have is a rotating magnet and then some stationary coils which are linked together with an iron core. Now basically what will happen is that rotating magnet will be linked to the fans of the turbine, and the coils will remain stationary. Now it doesn't matter if the magnet rotates or the coils rotate, but what you will notice about the magnet is that the magnetic poles are diagonal, which means that you're continuously moving from North Pole to South Pole. This causes a change. A change linked with Faraday's law means a change in flux. Change in flux over time is going to generate an EMF or a voltage. So basically what we get is an EMF which is produced due to this kinetic energy which causes electrons to be moved, and this electric movement we call a current or basically a voltage, because the voltage give the electrons the energy to move from one place to another. Okay, so let's go through that in more detail and break down exactly what's going on. So as we know, we get a change of flux which generates an EMF. Now this is basically because what we've got is a coil or a magnet. In this case we're going to be looking at a coil. A coil is going to move from an area where there's a large force, i.e. we're going to have a lot of magnetic field lines, to an area where there is less. Basically we go from a large magnetic flux to a small magnetic flux, or from a small magnetic flux to a large magnetic flux. Now if we look at these diagrams here that you can see, in the first diagram, diagram A, we've got our coil which is running in the same direction as the magnetic field. Remember that the field lines which are generated on the coil are going to be below and above. Those are the ones that we're interested in. So they're running either parallel below or parallel above, and they'll either construct or deconstruct. Now we know that from what we've looked at already, that when we're horizontal we get maximum force. However, as we start to turn and go up to vertical, we go to a zero force. Now that zero force is generated because we get a change in magnetic flux. That change in magnetic flux is going to cause a force on those electrons which is going to push them round. Hence we've generated our voltage. Remember, EMF and voltage is the amount of energy given to a coulomb of charge. So this movement of the fan causes the electrons to cut through these field lines. So this is another way of looking at it. If we get movement which cuts through these field lines, we're going to generate more EMF because we're going to get a greater change in flux. So you can see here that as we go through a quarter turn, basically we go from maximum change in maximum force down to zero force. Okay, so basically what we've got is an idea that we are continuously going from one position to another position, and then as we come underneath, we go from one position to another position, maximum to zero, zero to maximum, maximum to zero, zero to maximum, and so forth and so on. This is a continuous change in magnetic flux that will change with time depending on how quickly the fan will spin. Now what that does is, because we're going from this position to this position to this position, and then from this position to this position to this position, we get a diagram as shown in C. Now if you look at that closely, that's basically a cosine curve, which is part of a sine curve. So if you imagine right at the beginning where we've got maximum flux, you can see that the EMF is going to be greatest because we're moving from maximum to zero. When we get to zero, we've gone a quarter turn. Now you can see that the EMF at this point is zero because there's going to be nothing which is going on. Then we go back to maximum, so we're going in the opposite direction. Then we're coming back to zero, then we're going back to maximum again. So as a result, all we're showing is the positive and negative is just showing the direction that the force is going to be generated, and hence the EMF. So if we look at this in a little bit more closer detail, we can see in the first instance, you can see on the position of the armature in red there is at horizontal. We're going to get maximum force which is generated, so we get maximum EMF. It is going to be moving to zero. Okay, so as we move to zero at a quarter turn, we've got zero EMF because there's no flux. Okay, because there's no flux, there's no change in flux, so as a result we get no voltage. Now we're going to go in the opposite direction. Okay, so we're coming underneath, that's why the curve then goes under the x-axis, until eventually we get into our maximum position again as we move round. We keep moving, we keep moving, we keep moving, we keep moving, and as a result we keep moving back to our original position. Overall, we then get a curve which has maximum EMF at the top, drops down to zero, then as it goes into the other side of the curve, drops to maximum, then comes back to zero, then drops back up to maximum again as we move from zero force to maximum force. Okay, so we've got two types of generators which we can produce. We've got DC generators. In this case, the commutators are linked with a split ring, so they're continually changing. So what we'll get is, for a DC, because we're continually changing our direction, what will happen is 1 minute it's going to be positive, the next it's going to be negative. What we get is a curve which is shown on the right hand side. Notice that everything is above the line, okay, because as soon as it changes from maximum to zero and then goes back to maximum again, what's actually happening is that we are changing our polarity. So as a result, the terminals keep changing, so it continually shows the same curve. Everything is going in the same direction all the time. However, if we look at an AC current, what we have is the poles of the commutator, the terminals, always stay either positive or always stay negative. And what we'll get is a flipping between the actual turns, and as a result, we will get our AC curve. Because basically what's happening is, as we move around, we're going to generate different forces. Okay, well, I hope that makes sense, and you get the idea that basically we can use this idea of electromagnetic induction to produce our electricity. Remember, this is probably one of the most fundamental phenomena that we've got at the moment, because it's used all the time. I would be very surprised if there's anything where we do not use this process every single day of our lives, especially in the West. Okay, so what I've tried to do is put another video together, again using FET, and this video hopefully will explain that promotion and how we get those electrons which are generated. Okay, well, thank you for watching me, and I look forward to you joining me again.